Well, our joke's a little long today, but hopefully the punchline is worth it. A statistics professor plans to travel to a conference by plane. When he passes the security check, they discover a bomb in his carry-on baggage. Of course, he is hauled off immediately for interrogation. I don't understand it, the interrogating officer exclaims. You're an accomplished professional, a caring family man, a pillar of your parish. And now you want to destroy that all by blowing up an airplane? Sorry, the professor interrupts him. I had never intended to blow up the plane. So for other reason did you try to bring a bomb on board? Let me explain. Statistics show that the probability of a bomb being on an airplane is 1 out of 1,000. That's quite high if you think about it. So high that I wouldn't have had any peace of mind on that flight. And what does this have to do with you bringing a bomb on the plane? You see, since the probability of one bomb being on the plane is 1 out of 1,000, the chance that there are two is 1 out of 1,000,000. If I already bring one, the chance of another bomb being around is actually 1 out of 1,000,000, and I am much safer. So we're going to go over his calculations. Obviously, there's an issue, but let's start out with talking about probabilities. So a random phenomena is a situation in which we know what outcomes could happen, but we don't know which particular outcome did or will happen. The probability of an event is its long-run relative frequency. Does this mean we can predict particular individual outcomes with certainty? Not quite. Does this mean we can talk about what will happen in the long run? Actually, yes. For any random phenomenon, each attempt or trial generates an outcome. The outcome is what happens during the trial. So I've set up this spinner experiment on Shodor, which has virtual manipulatives. I've got purple, then I couldn't do black, so I did white and silver, or gray, and I set those both to 25%. So based on these areas, you would predict that, let's say I did a total of 4 spins, I would have 2 purples, 1 white, and 1 gray, right? So that's what I would predict. And on one spin, I would get a 50-50 shot of getting purple. So let's see what happens when I went ahead and played with this spinner. So here we go. Purple, that's fine. Let's do it again. Purple, wait a second, I'm at 100%. The next one can't be purple, but it is. Well, not the next one, we won't have another purple. Got another purple. The spinner must be broken, don't you think? Let's try again. Okay, we got another purple. We got 100%. And another purple. 6 purples in a row. Wow. Finally, we got a white. Okay, it'll settle down now. Wait, we got another purple. And then a purple. I thought we were going to get a gray on that one. And a gray finally. So the thing is, this is not behaving very well. Why is that? We've only been doing 1 spin at a time. Now when we start adding more spins, you can see that the percentages are getting much closer to the predicted. Let me add 1,000 spins. And in the long term, yes, I got purple 50% of the time and the white and gray each about 25% of the time. So it behaved. So the point is, when you're looking at individual events, probability is great, but it's not going to tell you for sure what's going to happen. It will give you a very good rough idea of what will happen in the long term if things are behaving as they should. So what did we learn from the spinner experiment? We learned the law of large numbers. That basically says, in the long run, it's going to kind of behave closer to what we expect in terms of true relative frequency. But in the short run, we have no clue. So consider flipping a fair coin many, many times. Can you predict what each flip is? Well, no, of course not. But you can predict the percentage of heads. The overall percentage of heads, if it's a fair coin, should settle down to 50%. The common misunderstanding of the law of large numbers is that random phenomena are supposed to compensate for whatever happened in the past, kind of like we kept getting those purples over and over again. This is just not true. So When flipping a fair coin, if heads come up on each of the first 10 flips, what do you think the chances are the tails will come up on the next flip? It's still 50%.